Buongiorno, I am instructor de mathematical Wilson Magnifico. Today you are going to be learning how to understand, to represent and solve equations with variables on both sides, and then we're going to apply this to real world scenarios and situations. Now, I know that in the 8th grade level, it asks you to start out instantly by solving equations with variables on both sides. I like to backtrack to make sure that all the gaps are filled in with your knowledge of equations, especially the vocab, and what terms and unlike terms are, and what coefficients and constants and operators are, before we move into any of that. Because if you don't understand the vocab, or the language of math, you don't understand that, you will have no idea what I'm saying. When I'm saying to you, all right, so looking at that operator, what's your coefficient and what are you going to do with it? You're like, what? You mean the thingy there? That thingy with the thingy, and you do the little num line, and you like draw the line, and then there's a number, and then you got the answer. No. What we want to do is we want to learn the language of math. So in order to do that, we must figure out all the vocab related to just this simple equation right here. There's a lot of vocab that goes into it. Just so we can talk about it once again, so you're not saying this thing or that thing there, we have this simple equation, which is 4x minus 7 equals 5. Looking at this, I need you guys to start understanding that this equation is made up of multiple parts. We're going to start here with this term. This is called a term. And very specifically, this is known as the variable term because that is where our variable is. This is a variable term. I have a 4 and I have an x. Yes, Sydney?
No, I want to answer.
You want to answer? Well, hold on a second now. We'll get there. This term is comprised of two different parts. I'm sure we know what this is, right? What is this?
Variable.
That's the variable. That's my variable. Okay, so I know what that is. But I also need to make sure you understand the proper name for the number located next to the variable in a mathematical equation. Anybody know the proper name for 4? Corey? You know the proper name for it? I'll give you a hint. It starts with the letter C. Connor?
Coefficient.
It's known as the coefficient. So this term, that 4 is your coefficient, x is your variable. This right here, I'm sure you know the name of this, but don't write it in yet because that's not what you're going to call it. Whenever you see a subtraction sign, whenever you see an addition sign, multiplication or division, those are all known as operators or operations, depending on what you want to call it. I call it operators, you probably call it operations because that's what you're used to here in the United States. These are your operations. And what's very important is that you understand that this is not 4x minus 7. This side of the equation is comprised of two terms, a 4x and then the other term here. What's the other term here? Anybody have an idea? It's negative 7. One thing you can never say, this is not 7. This is negative 7. Negative 7. Don't say it's minus 7. Don't say it's subtract 7. Two terms, 4x, negative 7. And then on the other side, we have another term. What term is this? Anybody?
Constant.
Well, what is it though? What is this? What number is this?
5.
So it's not just 5, it's not just 5, it's
Positive.
positive 5. No, and this is not a coefficient. A coefficient is a number located next to a variable, specifically multiplication. And these are known as, Maria said it, those are known as constants. Constants are numbers that are not connected to variables. They're not connected with multiplication, they're not connected with division, they're their own specific numbers. They're not numbers you've dealt with before. Integers, positive, negative numbers, they could be decimals, they could be rational numbers, whatever. They are just not connected to variables. So, coefficient, variable, constant. And all together, that is an equation. However, if we were just to look at the 4x minus 7, if I were to take away the equal sign, what's that called?
An expression.
It's called an expression. That is an expression. The difference between an equation and an expression is just that little equal sign right there. So that little equal sign now turns this into an equation. And all of these things right here, I have 1, 2, 3 of them. All of these are your terms. And I have two different types of terms. I have like terms, and I have unlike terms. Remember back when you guys were dealing with fractions, when you had like fractions and unlike fractions? So if you had 1/5 and 1/5, those were like fractions. If you had 1/5 and 1/4, those were unlike fractions. Similar rules followed here. Like terms are terms whose variables and exponents are the same. So we have terms like 4x and 3x. Those are like terms. Or -7 and 5. Those are like terms. It doesn't matter if they're positive or negative. All that matters is that they have the same variables, same exponents. And constants are also like terms. So in this equation, I have two like terms. I have -7 and I have 5. Those are like terms. 4x, that's the only variable term I have. So if I look at -7 and 5, I could say that these two are like terms. But what if I look at 4x and -7? Are those like terms? No, those are unlike terms. Why? Why are they unlike terms? Why are they unlike terms, Madison?
Because there's no variable.
Because that has a variable, that does not. These are constants. Those are like terms. That's a variable term. That's a constant. These are unlike terms. So unlike terms are terms whose variables and their exponents are, see if you can fit this in here, not the same. Try to fit it in there. I know there's a lot of space. Not the same. Don't say different. No, say not the same. Same and not the same. So that is just the beginning. That is just some of the vocab that you need to know when we solve equations. And I am very, very anal retentive about you using the proper vocab. Also, never, ever do I ever want to hear you say plug it in. We don't say plug it in. This is not a Glade commercial. We say what? We say substitute. So later on when I say how would you check your answer, you can say, well, I would substitute 8 into the equation to see if it works as an answer, if it works as a solution. But don't say plug it in. I know it's a hard habit to break because it's something that most of you come in here with. We say substitute. And there is a very, very important reason for that, which you will see when we get to Module 8. Why we don't say plug it in, why we say substitute. If you can train yourself to say substitute, it's going to make Module 8 that much easier for you. Plan ahead. Be prudent. Always have an eye toward the future. Prudent means have an eye towards the future. Okay, we're starting off about as basic as you can get here. I'm sure that all of you know how to solve these equations. Definitely this one, definitely this one, definitely this one, and I'd say most of you even know how to solve this one. The reason I start off at such a basic level is to see if you guys remember all of the basic rules. If you don't remember any of the basic rules, or if you've learned one of them incorrectly, it's going to make everything else you do fall apart. You know what happens when you line up a string of dominoes and you tuck just one over? What happens to the rest of the dominoes? They all fall over. Same thing here. When you're solving equations, if you do just one thing wrong, you carry one sign wrong, you do one operation incorrectly, then all the work that you do is going to be wrong. What's up?
Like you're talking about dominoes because
if you line up all the dominoes, like a long string of dominoes, if you took just that one domino over, what happens to the rest of them?
they all fall, but what
They
I
all
did
fall
that
down.
in midway,
Uh-huh.
the mid one didn't stop. It didn't fall down.
Well, because they weren't close enough together.
No, they-
But when we deal with equations, if you tip over one domino, believe me, everything else is going to fall down with it. All right, let's start off basic, basic, basic. Whenever I teach students to solve equations for the first time, just like when you first learned how to ride a bike, I like to give you guys training wheels. My training wheels are in the form of this line right here. When we solve an equation, the first thing we do is we draw a line through the equal sign. And we separate the equation into, Chris, we separate the equation, we draw this line, and we separate the equation into two different parts. The reason for this is because when we're solving equations, we must remember, I'm sure you all know that what you do on one side of the equation, you must do on the other. But this makes it very visual. If I have something on one side of the line, I must mirror it. I must have the exact same thing on the other side of the line. These training wheels do help. Eventually, you'll be able to get rid of them, just like I'm sure. None of you use training wheels for your bikes now, right?
No, well,
Sometimes? No? Okay. Most of you, I would assume, don't use training wheels. And as we go through equations, you probably will stop using this line, but for right now, everyone in here draws the line. Once you're proficient, not just in these, but I'm saying when you're proficient with stuff like this, as we move on, or you're proficient in stuff like this, combining, and you're proficient with stuff like this, then remove the line. For right now, use the line. Okay, so when we solve an equation, the goal, always, the goal is to get the variable, in this case x. The goal is to get the variable, in this case x, alone, by itself, on one side of the line, on one side of the equation. You must have a positive x, and it cannot have any numbers next to it. You can't have a 3x. You can't have a negative x for it to be a solution. You have to have a positive x all alone by itself on one side of the equation to indeed be a true solution. Now we start off easy here. This is x, a positive 5, and an 8. When we are solving equations, we use inverse operations in order to get x alone. Who knows what the word inverse means? It means opposite. So we do the opposite. Whatever this term is, we simply put in the opposite term. So what is this term right here? Don't say plus 5. It's not plus 5. It is positive 5. There's a reason I'm really anal retentive with the vocab. So it makes it easier for you. Positive 5, the opposite of positive 5 is a negative 5. So negative 5, negative 5. And then what is going to happen to these two 5s here, guys? Cancel out. And then you work from left to right so you don't make mistakes. And you bring everything down. You bring down the x. You bring down the equal sign. And 8 minus 5, simple subtraction. What's 8 minus 5? 3. Simple. That one's done. How can you check to see if that answer is correct? What can you do? Lucas, what can you do to check to see if 3 is correct?
You do the opposite way, like you, instead of subtracting getting your answer, you add 8, and, you add 5 and 3, and you get your answer. Okay,
so what you're trying to say is you would take this 3, I understand what he's trying to say. You would take this 3, you would substitute it into the original equation and see if it's a true solution. Now, if you took 3 and you substituted it in here, you would get 3 plus 5. What's 3 plus 5? 8. You would end up with 8 equals 8. That is what's known as, we'll come back to this at the end of this module, that's what's known as a true statement. That is indeed a solution to this equation. If I were to substitute in a number and I were to get 7 equals 8, do I have the right answer? No, I do not. It must be balanced. You must have a true statement. Is that a true statement? Does 7 equal 8? No, that's a false statement. That would be not a solution. But 8 equals 8, that's true. That's a true statement. That is indeed a solution. Simple equations. Let's go to Matthew. Yeah. Follow the steps that I just showed you, please. As we do this, what's the first thing I want you to do here?
Put the line through the equal sign.
Draw the line right through the equal sign, okay?
And then we do the inverse operation.
Inverse operation, so that's a negative 3. We're looking for a
positive 3.
Positive 3.
On both sides.
We put a positive 3 on both sides. What happens to these two 3s?
They're going to cross out.
They cross out, and then we work from left to right. We bring down the x, bring down the equal sign. 7 plus 3 is 10. Yeah. Some of you might be saying, man, this is easy stuff, man. I don't need to know all these fancy rules and stuff. Trust me, you do, because as we progress through this, if you don't follow the simple basic steps here, and you don't know the vocabulary, you don't know everything else that's involved in this, when we get to equations that look like this, you will have no idea how to solve them. You must know the rules here in order to solve those equations right there. So, we move on to the next one. Fiamma, Matthew, I owe you, take it. Fiamma, what's the first thing I do here? Put a line right through it, okay? So, what is happening here between the 4 and the x? It's multiplication. What's the opposite of multiplication? Division. So we are going to divide out the coefficient. We want to get x alone by itself. The opposite of multiplication is division, so I divide both sides by the coefficient. Common mistake is people don't divide by 4, they divide by 4x for whatever reason. You can't do that. You cannot divide 12 by 4x because they are unlike terms. I can divide both sides by 4 though. Those are like terms. 4 and 4, 12 and 4. What happens to those two 4s? They cancel, and x is equal to 3. And if you want to check this, what would I do, Maria?
You would substitute 3 into the equation.
I substitute 3 back into the equation. 4 times 3 is
12.
12. 12 equals 12. Is that a true statement?
Yes.
Yes, it is. Therefore, that is indeed the solution. Yes, Maria? You want to do the last one? Okay. I'll let you do the last one with me. There's one for you. And I'll pay you in advance. I'll give you...
Would the answer be x equals 3 or 8 equals 8?
For this one?
Yeah, for that.
The answer would be x equals 3. What this is, right here, is this is us going back and checking our work. So we take the 3, we substitute it back into the original equation. So the x is removed. We put in the 3. We know that's multiplication. So what's 4 times 3? 12. 12 equals 12. Is that a true statement? Does 12 indeed equal 12?
Yeah.
Yes. If it's a true statement, bang! You got a solution. If it's a false statement, man, you messed up somewhere. You got to figure out where you made the mistake. Boo boo. All right. Maria! What do I do here? What's happening between the x and the 4?
It's being divided.
It's dividing. So when we see division, what's the inverse or the opposite of division, guys?
Multiplication.
Multiplication. Now, you may have seen this in middle school, hopefully not, because this bugs me when I see this. Take a little denominator, a little circle, and you do this. No, you don't do that. Hopefully, when you learn this, because hopefully that's been banished, what you do is this. You realize that this is division. So you must multiply both sides by the denominator, which is 4. You wrap both sides in parentheses, and you multiply both sides by 4. What's going to happen to these two 4's here, guys? They're going to cancel out. Did we forget to do something when we started this problem, though?
Yes.
What did we forget?
You've got the line through
We
the
forgot to draw the line. Okay, so those 4's cancel out. We're going to have x is equal to what, Maria? 8. X is equal to 8. And then, Connor, how can you check that?
Oh, you can plug 8 in with it. Oh, you can substitute 8.
I was waiting for that. Substitute 8 into the original equation, and 8 divided by 4 is 2. Does 2 equal 2? Yes, 2 equals 2. That is indeed a true statement. Bam! That's the solution. What's up?
What if it wasn't an x on the top? What if it was like a 1 or something?
What if it was a 1 on top, like 1 over 4 equals 2?
Yeah.
Isn't that just saying that 1/4, that's not an equation though, right? Because we don't have a variable.
Oh,
Yeah, because if you were just to write 1 over 4 equals 2, that's not an equation. You're just saying that 1/4 equals 2. That's a false statement. I mean, it's not even an equation. For an equation, we got to have some type of variable there. We got to have an equal sign, and generally you want to have a constant, even if the constant happens to be 0, because x equals 0 as well. Okay, that's pretty much what you need in an equation. And of course, God, it'd be nice if they were all that easy, huh? What is 2x equals 30? It's 15! If that were as far as equations went, that would be awesome. Of course, we all know it ain't like that, right? It ain't like that at all. So, any questions on this first page? No? Alright, we'll pause there. We're going to lunch in a minute, and we'll come back. For right now, just get your stuff ready to go. Doesn't mean get up yet. I didn't say get up yet. I just said get your stuff ready. Alright, so no questions on this. Now let's move into two-step equations. Now, when we do two-step equations, we have to undo the order of operations in reverse. So you, when you were little kids, you went to elementary school, you, maybe 4th grade, something like that, you learned, please excuse my dear Aunt Sally, you learned PEMDAS. Since we're undoing the order of operations in reverse, we have to reverse this, and it becomes SADMAP. What that means is this. We get rid of that, and what that means specifically, you gonna write that in? Yes. What that means specifically is when we're doing two-step equations, the first thing you have to do, the very first thing, is undo any subtraction or addition first, before you do anything else. Once you've cleared out the addition or subtraction, bam, it's gone. Then you have to go in and deal with the division or the multiplication. As for the exponents in the parentheses, don't worry about that. We will come back to that at a later time. Know right now that you must always deal with subtraction or addition first, then you divide or multiply. Only after you've cleared everything else out from one side of the equation, such as the addition here, the subtraction here, and the subtraction here. Once you clear that out, then you deal with your division or multiplication. So, let's go through. Hopefully we remember the rules. Adriana, what's the first thing I would do here?
Draw the line.
Draw the line right through it. Hopefully we can actually go right through it. Hopefully we can actually go right through it. Okay, so we draw a line right through it. And then we're doing the order of operations in reverse. So, we have 3 terms here. We have a 3x, we have a positive 12, and a 36. I must get rid of that addition first. I have to get this variable term alone, by itself, on one side of the equation. Once I get the variable term alone, then I can get just the variable alone. So I have to undo this addition. What's the opposite, Adriana, of a positive 12? A negative 12. So we subtract 12 from both sides. Subtract 12, draw a little line, and we work from left to right. We bring down the 3x, What happens to these 12s here, guys?
Cross out.
They will cancel out. They'll become 0. The bases will cancel out and bring down the equal sign. And then what's 36 minus 12? 24. So we have 3x is equal to 24. So we've done one step. This is a two-step equation, which means there's one more step that we have to do. Now that we've taken care of that, let's go to Alicia. Alicia. So I've undone the addition. Now I have to get rid of the division or the multiplication. What's happening here? What's the opposite of that? Division. So we're going to divide both sides by what? By positive 3. Why? What is positive 3? What's the proper name for it? Starts with a C. Coefficient. We're going to divide both sides by the coefficient, which is positive 3. So we divide positive 3, positive 3. What happens to these two 3's, guys?
Cancel out.
Cancel, cancel, and you bring down the x. What is 24 divided by 3?
8.
8. 24 divided by 3 is 8. And then how could you go back and check your work, Lucas? How could you go back and check it?
You substitute the x for, wait, no. Yeah.
You substitute the solution, 8, into the original equation, 3x plus 12 equals 36. If you get a true statement, in this case 36 equals 36, you have the correct answer. And it would work. 3 times 8 is 24, 24 plus 12 is 36, 36 equals 36, that's a true statement. Yes? When we get to the one, yes you can. Question?
So do we always have to check it just to make sure?
I would check it. It's a really good habit to get into, check your work, because you always have time to check your work. You will. I know when you do tests, you look up, and I got like 30 minutes left in class, I'll turn it in, I'm good. Go back and check, because you could have done everything right. But let's say, whatever, for whatever reason, I just had a mental error, and here, instead of subtracting 12, I just made a quick mistake and I added 12. Now I'm going to have 3x equals 48. When I divide out, I'm going to get x equals 16. It looks like I did everything right. I don't check it, I turn it in. Do I get that right or wrong?
Wrong.
I get it wrong. But if I went back and checked, I'd see that I did it wrong. If I went back and substituted in 16, I would get 48 plus 12, and we all know that 60 does not equal 36, right? Does 60 equal 36?
No.
No, it does not. That would let you know that you did something wrong. You're like, oh! Oh! I added. I was supposed to subtract.
What if we do that?
And you correct it. And then, instead of getting the wrong answer, now you got the right answer. And that's another reason math matters. All right, let's move on to the next product. Candy cane. Maria, what am I doing here? What's the first thing I do?
You put a line through the equal sign.
I put a line right through the equal sign. Okay, I got my line. Got my line going. And then what's the first thing you're going to do? Looking at our order of operations reverse, what are you going to do?
You are going to add 6.
I'm going to add 6 to both sides to get rid of the negative 6.
Yeah.
If I add 6 to both sides, I will remove the negative 6. I will isolate my variable term on one side of the equation. So I'll bring down the x over 2. Those will cancel. Cancel, cancel. Equals 24. So x over 2 is equal to 24. And then let's go to Fiamma. What would I do now?
Inverse operation.
Okay, what's the inverse operation? What's happening between the x and the 2? Well, no, I mean, this is multiplication here, right? Yeah, that's dividing. So what's the opposite of division? Multiplication. What are you going to multiply both sides by? Okay, so we look here. Let's back it up a step. Look here. See the 3 in the x? So we wanted to undo this multiplication. So we divided both sides by 3, the coefficient. This is not called a coefficient, it's just the denominator, but we want to undo this division. So I must use the denominator. The opposite of dividing by 2 is multiplying by 2. So I'm going to multiply both sides. What happened? What is all this stuff? It just appears here. Looks like my board's got freckles. Alright, so I'm going to multiply both sides by 2. What happens to these 2's right here? They will cancel, cancel, and you're going to have just an x over here. That's all that's left. What's 24 times 2? 48. 48. See? 48 is the answer. And if you want to check it, go back, substitute it in. 48 divided by 2 is 24. 24 minus 6 equals 18. 18 equals 18, true statement. Good answer. Good answer. All right, thank you. Next one. I know you're like, I didn't know how to do this, man. It's so easy. Why are you teaching us this easy stuff? Because maybe some people are learning a thing or two. Let's see, and I'm sure they are. One. What am I doing here, man?
So you
Bottom left, tell me, what's the first thing you want to do?
draw a line through the equal sign.
Draw a line through the equal sign. That works for me. What do I do on one side of the line? I must do on the other side of the line. Okay. What do I do next?
And then you're gonna add 3 because there's a negative 3.
Yeah, there's a negative 3, so the opposite of that's positive 3. So I add 3 to both sides
And then
of the
you
equation.
cancel out the one that's negative 3 plus positive.
Okay, those will cancel, and then we work from left to right. So I bring down the 1/2 x. I bring down the equal sign, and then what's 5.5 plus 3? 1?
8.5.
8.5. Okay, 8.5. Let me clean up my 2 over here. Looks like you got damaged in transit. 1/2.
Read that on the left.
So I have 1/2x is equal to 8.5. Now, what would I do in this scenario? Already colon. Dylan, what are we going to do now?
Now you would have to divide by 1/2.
Okay, so we divide both sides by 1/2, but don't write anything. Don't write any dividing by 1/2. What happens when you divide fractions? When you divide fractions, let's just see if you remember this. I have 1/2 divided by, what'd you say? We're going to divide both sides by what? By 1/2, right?
Yeah.
So, see if you remember back. When you divide fractions, what do? You probably remember some silly little Z. Some of you remember the chicken restaurant, the KCF or something like that. The mathematical term. I don't use keep, change, flip. What is keep, change, flip? You keep it, you change it, you flip it. Yes, you know that. But the truth is, here's what you're doing. What you're in effect doing is you're multiplying both sides by the, it starts with an R, the reciprocal. So here's what you do. You do, in fact, keep this. The division does switch to multiplication. And then what is the reciprocal of 1/2? 2/1. When you see reciprocal, here's what I need you to understand. The reciprocal is simply the fraction flipped upside down. So the reciprocal of 1/2 is what? 2/1. What's the reciprocal of 3/7? 7/3. You're just going to multiply both sides by that reciprocal. So when I get to this point, and I have 1/2 being multiplied by x, I am going to divide. But when I divide, I multiply both sides by the reciprocal. That's what we're doing. So we multiply both sides by my reciprocal. What did I say the reciprocal was here? 2/1. 2/1. 2/1. And then let's go in and let's examine what happens here. When we multiply fractions, do I cross multiply or do I multiply straight across? Straight across. What is 2 times 1? 2. What's 1 times 2? 2. What's 2 divided by 2? 1. And 1x is the same as writing just x. So all I have left over here is just x. That will cancel, cancel. Equals. How do I multiply a decimal and a fraction? Cindy, you have your hand up?
You put the fraction over 1.
Well, the fraction's already over 1. You put the decimal. In this case, decimal, usually we say whole number, but this is a decimal. I put that over 1. So, what is 8.5 times 2? Anybody?
17.
17. What's 17 divided by 1? 17. So x equals 17. And that's it. I want you to understand, I'll let you guys write that in. Finish writing that in, please, real quick. And I want you guys to understand that there is a huge difference between this and this. That's division, that's multiplication. Now you will end up multiplying both of these, but you have to remember, it's when you see a fraction next to a variable. It's very similar to when you see something like 4x. The only difference is now, it's a fraction. When you see a fraction next to a variable, boom, light should go off in your head. Fraction next to a variable, reciprocal. That's what we do. We flip the fraction and we multiply both sides by the reciprocal. Of course, make sure you undo the addition or subtraction first. And of course, we can always go back and check our work. So what was my solution for this? Dylan, what was my solution?
Your solution was x equals 17.
So x equals 17 was my solution. So I can take my solution, I can go back and I can substitute it in to the original equation. 1/2 of 17 will give me 8.5 minus 3 equals 5.5. Make sure you're writing this in. What's 8.5 minus 3? 5.5. So 5.5 equals 5.5. Is that a true statement?
Yes.
Yes, that is a true statement. That is in fact a good, yummy, delicious solution. Any questions on this? Any questions on this at all? No? Okay. Okay. So, go. 4, 3, 2, 1, por favor. What's up? All right. So, how many of you are able to do simple addition, simple subtraction of 1 or 2 digit numbers? For the most part, right? All of you? Can you do simple addition, simple subtraction? Yes? Yes? All right. Then combining like terms should be very easy for you. All you need to remember is what like terms are and what unlike terms are. You also must keep in mind that the operator is part of the term. So if I look here and I want to combine these terms, if I want to combine these terms, I have to go in and I have to identify all of my terms. So working from left to right, I want you guys to tell me what these terms are. What is this term, guys?
9x.
You're missing something. What is it?
Positive 9x.
Positive 9x. What is this?
Positive.
Positive 3. What is this?
Negative.
Negative 4x. Everyone should be saying this, because if not, it's not building in your brain. Emily, what is this? Negative 7. Say it loud, guys. And what is this?
Negative.
Positive 6x. And what is the last term?
Negative
10. Okay, so here I now have identified what all my terms are. Now I need to identify the like terms. So looking here, I have 3 variable terms and I have 3 constants. So I'm going to split them apart so that I can combine them. First, let's deal with the variable terms. Going through this, now guys, tell me, what are my variable terms here as we work from left to right? The whole class, what's the first variable term?
Positive
9x. What's the next term?
Negative
4x. Never forget the symbol. And what's the next term?
Positive 6x.
6x. So we split those apart. Done, done, done. Now I have my constants. Those are also like terms. Oh, but some of you are like, wait, there's positive and negative. That does not matter. They're all constants. They do not have a variable. Therefore, they are like terms. Look, some of these are positive and negative, right? Isn't that positive? Isn't that negative?
Yep.
Does that matter?
No.
No. All that matters is that all of these have the exact same variable, right? X, X, X. Do they all have the same exponent?
No.
Yes, they do. What invisible exponent do they all have? 1. They all have an exponent of 1. So they all have the same exponent. They all have the same variable. Positive or negative do not matter. Now, we combine the constants. Left to right, what are the constants, guys? Positive 3, negative 7, negative 10. Okay, now that we've identified all of them, we've written them all together, now we're going to combine them, which means we're going to simplify these 2 expressions. We're going to follow the operations, and we're going to smush them all into a single term. These 3 terms will smush to become 1 term. So, working from left to right here, what is 9 minus 4? 5. And what is 5 plus 6? 11. So this becomes 11x. Positive 11x. Thank you. Positive 11x. Now we work with combining the constants. Be careful here. This is just simple addition and subtraction. Sometimes you will have negative numbers. You have to know how to do these numbers. What is 3 minus, and this is a 7, just to make sure, what's 3 minus 7? Negative 4. Hold that in your head. Now we have negative 4 minus 10. What is negative 4 minus 10?
Negative 14.
Negative 14. And then we can just rewrite the expression. We combine these 2 terms together. I'm going to write my variable term first, 11x. And then what is this? Positive or negative? Negative 14. So once I combined all the terms, I now have a simplified expression. That's how easy it is to combine like terms. It is not a difficult process, but it is something that I see students struggle with sometimes. Why? I'm going to show you on this side. Here's the most common mistake when people try to combine like terms. Remember that we said we have 2 different sides to an equation, right? We have the left side of the equation and we have the right side. And we always draw a line. The most important thing I can tell you about combining like terms is you can only combine like terms on the same side of the equation. Even though 20 and 38 are like terms, I cannot combine them. If I wanted to have 20 interact with 38, I'd have to use my inverse operation. The opposite of a positive 20 is a negative 20, yada, yada, yada. What I'm trying to do right now is not that. I'm trying to combine like terms. So I look at the left side of the equation first, and I ask myself, on the left side of the equation, do I have any like terms, yes or no?
Yes.
Yes, what are my like terms on the left side of the equation?
Positive
Positive 13x and positive 17x. So we're going to combine these. What's 13 plus 17? 30x. So that becomes positive 30x, and we bring down the positive 20. We bring down the equal sign, okay? So I combine all the like terms on the left side. Now I want to combine all the like terms, if there are any, on the right side. So, Ali, on the right side, any like terms I can combine?
Yes.
Yes, I have constants over there, right? I have two constants. Those are like terms. My constants are like terms. So, what are my like terms here?
38.
38 and?
38 and negative 2.
Positive 38 and negative 2. I can combine those like terms. What is 38 minus 2?
36.
36. So I combine these, and I get 36. I bring down my 28x. And then I need a symbol here. I need an operator. So this is positive 36. So what symbol do we use? A plus sign. Don't forget that plus sign. You can't just write 28x into 36. Let me clean this up because it's gotten a little messy here now. That's going to be 28x plus 36. I'm not going to solve this yet. I'm going to do that on the next slide. But I'm not going to solve this yet. All we were trying to do here was combine like terms. And when you see an equation that has like terms on either side that can be combined, that is your first step. Before you deal with addition or subtraction or anything else, you always must combine your like terms. Any questions on this? Any questions? No? All right. 4, 3, 2. All right. All right. So now we actually move in to what we came here to do. Solving an equation with variables on both sides. You will see these steps over and over again. I use them, so should you, to help avoid simple mistakes. When we're solving an equation with variables on both sides, as you can see, we have a variable term on both sides. I have a 30x and a 28x. First thing you always ask yourself, so are there like terms that I can combine on either side of the equation? So we draw our line. Are there any like terms I can combine over here, class? Yes or no?
No.
No. Any like terms over here?
No.
No. Okay. So the answer to that is no. We move on to step 2. Step 2. Using inverse operations. Believe me, use these steps. They make it almost impossible to get these wrong. Using inverse operations, you move the variable term with the smaller coefficient to the other side of the equation. What does that mean? Okay, so we look at our variable terms. What are my variable terms in this equation, guys?
30x and
30x, positive 30x, and positive 28x. Which one of them has a smaller coefficient? 28x. So that's the one I'm going to move. And the reason, can anybody tell me the reason I'm moving the smaller one?
So that number will be easier. Smaller.
Keep in mind, remember I had you set up y2 and y1 a certain way, so we avoided what type of numbers? Negative numbers. If I move the smaller one over here, I'll be subtracting 28x from both sides, right? I'll end up with a positive x. If I were to move this over here, now I have a negative 2x. That's just one more area I can make an error on. So we're going to move the variable term with a smaller coefficient. So this is a positive 28x. What's the opposite of a positive 28x?
Negative.
Negative 28x. So I'm going to subtract 28x.
You can't subtract the x.
I said I couldn't divide out the x. I can subtract the x.
When you
Are we combining like terms right now?
Oh, no.
No, we're using inverse operations to move terms from one side of the equation to the other. And I cannot subtract 28x from 20 because those aren't like terms. But I can subtract 28x from 30x. I'm using inverse operations to move this term from here to here. Because remember, the goal when I'm solving an equation is to what? Get x alone by itself, right? So to get x alone by itself, first, I just need to get my variable terms, my x terms together. Then I can go and get rid of the coefficient, right? First step, let's get them together. When we get them together, here's what happens. Watch this. What's going to happen to these two 28x's?
Cancel out.
They're going to cancel out here. Cancel, cancel. And you're going to see that I end up with 2x plus 20 equals 36. Do I have all of my variable terms together? Yes or no? Lavin?
Oh,
Yes, I do. I have now just one variable term. I have a 2x And this just turns into a two-step equation now. So we go back to what we learned a second ago. Sad math. I must undo the addition first. Where's the addition I have to undo here? Let's go to Brianna. Where's the addition I have to undo? The 20, the positive 20. I have to undo this to get my variable term completely alone. I need to put it on the lonely island. What's the opposite of a positive 20? So I subtract 20 from both sides. That's step 3. Using inverse operations, move all the constants to the other side. So now I'm moving all my constants to the other side of the equation. I end up with 2x is equal to, what's 36 minus 20? 16. And I have now narrowed all this down into a one-step equation. I have my variable term alone on one side. I have my constants on the other side. The last thing I have to do is get rid of the coefficient because I need to get x alone. So I think who was the last person who helped me? So you take it. Who's the last person who helped me? That was Brianna and Connor. And you, well, you asked me a question, so I'll give you a check with that one now. There we go. There we go. Calco, you got a question? Or you want to finish? You want to finish this? Ah! All right. So Calco, we have multiplication happening between the 2 and the x. What's the opposite of multiplication?
Division.
Division. What are you going to divide both sides by?
2.
Why? What is 2?
2 is a coefficient.
2 is the coefficient, so I'm going to divide both sides. Note, I'm not dividing by 2x. I cannot divide by 2x. I divide both sides by just 2. 2. What will happen to these 2's?
Cancel out.
Cancel, cancel. X is equal to
8.
8. And if I wanted to check this, I would take this and I would do what with it? Substitute it into the original equation. I substitute it here, here, and I would see that I got a true statement, because that is indeed the correct answer. Any questions on this one? We pick up the pace here a little bit. Okay, everyone have this written in?
Yeah.
Yes.
All the notes, not just the parts you like to write in? All of it? Okay. Okay, so let's try another one. Let's go to Sebastian. Chavez. Okay. First question you always ask yourself. Step 1. After I draw my liggity line, right there, are there any like terms that I can combine on either side of the equation? Yes or no?
Yes.
Yes. Which side?
The left side.
On the left side, okay? So we go to the left side, we must identify our like terms, working from left to right. What terms can I combine?
15x.
Positive 15x and
Negative 7.
negative 7x. Do not forget the operators. So we need to combine these. Yes, there are like terms. I will combine these terms and I will rewrite this equation. So class, what is 15 minus 7?
8.
15 minus 7 is 8. I said 15 minus, not 15 plus. Somebody said 22. It doesn't matter. 15 minus 7 is in fact
8.
8.
Negative.
X. 8x.
Do you want to build a snowman? It's a melting snowman. 8 x. I bring down the negative 3. I bring down the equal sign. I bring down the positive 17. I bring down the positive 10x. Okay. So I combined my like terms. Yes, what's up?
Wouldn't you do the first, the smaller number?
Well, we're not moving it from one side to the other, are we? You're talking about this step right here, using inverse operations to move the variable term with a smaller number. That's once we combine like terms. We will always check to see if we combine like terms first. So we just treat it, originally here, we're just treating this as 2 separate expressions. Now, we are actually dealing with an equation, because I combine my like terms. So I have 8x minus 3 is equal to 17 plus 10x. Okay, so I go into my rules. Rule 1, now that we're solving this equation. We identify the variable term with a smaller coefficient. Looking up at this board, flash. Savior of the universe. Flash. Which one of these variable terms has the smaller coefficient? 8x. That has a smaller coefficient, so what I'm going to do is I'm going to, that's a positive 8x. What's the opposite of a positive 8x?
Negative 8x.
Negative 8x. So I subtract 8x from both sides. Oops. That's a mistake. From both sides of the equation. What? Yes? No, I'm not trying to get rid of the coefficient. I'm just trying to get all of my variable terms together on one side of the equation. Yeah, this is one of those new things now. When you move into equations with variables on both sides, we start adding layers. It's like an onion. There's always more layers to equations. This is the next layer of the onion. So we subtract 8x from both sides. What's going to happen to these 8x's, guys? They're going to cancel out. I'm going to bring down my negative 3. I bring down my equal sign. I bring down my 17, and I bring down, what's 10 minus 8?
2x.
2x, positive 2x. Okay. Now I've turned this into a two-step equation. You guys with me so far? Yes or no?
Yes.
Okay, Chris. I have all my variable terms together. Now I must get all my constants together. So I've got to take this term, I gotta move it over here. What's the opposite of a positive 17? Negative 17. So I subtract 17 from 17. I subtract 17 from 3. And what's going to happen to those two 17s, kids? Cancel, 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 cancel. And I end up with negative 20 is equal to 2x. Now, Viviana, what do I do? Oh yeah, it's negative 20. Same sign, add and keep. So 17 plus 3 is 20. They're both negative, so it's negative 20. All right, so Viviana, what do I do now? Thing is, you know how to do this. Don't be confused. We have negative 20 equals 2x. I must undo this multiplication. The opposite of this multiplication is division. So I'm going to divide both sides by 2. Why? What is 2, class? What is 2, class? Coefficient. So I divide both sides by just 2, not 2x. And what's going to happen to those 2's?
Cancel out.
They cancel. X equals, and then class, what is negative 20 divided by 2? Negative 10. So x equals negative 10. Yes, Sydney?
Wouldn't you subtract the 3 from each side because, the negative 3 to each side because it's equal?
Wouldn't I what now?
Wouldn't you subtract or add 3 to each side?
If I add 3 to both sides, don't write this. Oh, everyone has their notes. Everyone has their notes?
Yes.
All right, everyone has their notes, eyes up here. All right, so let's backtrack here. Let me show you what happens. Now, remember the goal is to get all the variables on one side, all the constants on the other, right? So, if you were to go and add 3 to both sides, here's what would happen. You would end up with 0 equals 20 plus 2x. Can you solve that? No. Well, you could, but now you have to go back and you have to subtract 20 from both sides because you need all the constants on one side, all the variables on the other side, and you still end up with negative 20 equals 2x. But now you have done an entirely additional step for no reason, right? So once you get your variables on one side, it should click in your mind. Now you want to get all the constants on the other side. You with me? That makes sense? Okay. Let's backtrack to the original notes here. Where are these? No. Okay. Yes, Connor.
When we write the like x equals negative 10, do you write negative 10 equals x or
You can write it just like that. Whatever way the solution ends up, leave it like that. You can write negative 10 equals x. If you want to write x equals negative 10, it's not wrong. Whatever. It does not wrong. As long as you're saying x equals negative 10 or negative 10 equals x, that's the exact same thing. Any questions on this? Any questions? No? Okay. So, 4, 3, 2 y 1, por favor.